Hello students, myself Tanishri Enuta and welcome to the lecture video on module 2 wherein we have already come across with our last class with basic file attributes and change in file permissions there. Okay, so wherein basic file attributes are nothing but wherein we have come across to know with our last class saying across as any file may not be identified only by a file name but rather it can be identified in multiple different parameters or else different ways there. Then we had come across whenever I say a file, okay, so file has a restrictive permissions there. So those permissions are read, write and execute respectively. Okay, so these permissions stand differently for three categories of people. Okay, who are these three categories of people? They are, the very first one is owner, the second one happens to be group members, and the third one happens to be others. Okay, so with respect to these three category of people, okay, who are working on a particular system, so there lies different permissions for them, so that I can enroll or else I can just say that I can acknowledge that my system happens to be in a secured way. Okay, that can be given by change of file permissions. So with our last class we have come across to know how can we adapt this particular change in file permissions there. This can be done in two different ways there. One is absolute way and one more is relative way. Okay, so then let us move across with our next section here, and that is wherein our study for today's class is regarding how does your shell interpret the things whatever comes onto its way here. Okay, so let us come across. Okay, that is our study is shell's interruptive cycle. Okay, so shell's interruptive cycle is nothing but, now like for example, of course all of you students know that what is high level language, what is low level language. Okay, so in what programming language you will be writing? You will be writing in simple English itself. Okay, textual way, but that is in form of instructive way. Okay, so such instructions in such a way that can be that is being understood by a particular language, and it will be converted further and we will be getting our desired output there. Okay, that is we usually say in our term saying that the high level language is converted into low level language. Okay, and then it has been devised and then we have our respective output there. Okay, so here our shell's interruptive cycle is nothing but wherein we are speaking about this particular prompt here, that is this is nothing but shell. Okay, so whatever comes onto its way, how does this shell interprets the things whatever comes? So that is our study for today's class. Okay, now like for example in simple analogy I'll just tell you, like for example I ask in English, okay, good morning. Okay, good morning, how are you? Okay, then in Kannada if I ask you for an interpretation, so you just say it, Shubha Munjane ಹೇಗಿದ್ದೀರಿ. Okay, so this is how we will be doing an interpretation. Okay, so that is in the same way we are having a study here of how does the shell interpret the command or else anything which comes onto its way. Okay, one best command which helps us to know these things in a better way is this particular command which I have listed here called as PS. PS stands out for process status. Okay, what all processes are running on that particular user or as on that particular shell is being identified by this particular command called as PS. Okay, now you can just see that when I use this PS as a command and press an enter key, you will get this 4 columnar display. Okay, what is this 4 columnar display? One is process ID, TTI, that is which terminal is active, since when is that person being logged in, or since when is the idle time for that particular user, and what is that particular user running. Okay, now as we have come across to know that it's a PID process 328 is running on terminal called out as PTS/2, and since the logged in time is 0.00, okay, then since then that is idle. So idle is nothing but that particular user is not in an idle position, that's a working one. Okay, and what are they working? They are working on bash, that is on shell. Okay, so this is about this particular user here. Okay, now so you can just come across the same interpretation is given here. The bash shell is running at the terminal PTS/2. When you key in the command, it goes to shell as an input. Okay, now whatever you type here, it is the input to this particular shell. Okay, So now this is being processed and it is being given as in a form of output here. Okay. So the shell scans the command line for meta characters. Now our botheration is if at all shell faces any kind of meta characters here. Okay. As we all know that meta characters are nothing but special characters or symbols. Okay. That can be asterisk, that can be a question mark, a slash, a hash as a key. All of them are being considered as meta characters or special characters. Okay. Now these all, why it is being given such a botheration or why it is given so much of importance is only because these all special characters can be used as a part of a file name. Okay. Only because of this, what happens is your shell plays a very important role to get its respective demand. Okay. How should it interact how should it interpret in a way whenever it comes across with such a kind of a meta character? Okay, at that time how your shell should interpret. So that is the main botheration. Okay, so that what we are coming across here. Okay, so whenever it comes across, if a shell encounters, now example meta characters like these things. Okay, what it does, if the meta character is asterisk, then shell replaces it with the file names in the current directory. Okay, so that is nothing but asterisk stands out for. So I'll just go across with some examples further, then you will come across to know it in more detail there. Okay, we'll just shift to directly to the executions there, examples there. Okay, shell issues a prompt. Okay, this is an interruptive cycle which I'm going to say. Okay, issues the prompt and waits for you to enter the command. Okay, once you enter the command, like for example if you enter rm asterisk, okay, what will happen, this rm is treated as a command, but what it should treat to asterisk here. Okay, asterisk has a special meaning by the shell. Okay, and that is asterisk stands out for many characters. Okay, got to know, asterisk stands out for many characters. Okay, which can be replaced across with anything, any file name will be removed. So that's why be very cautious when you are using these meta characters. Okay, now further slides we'll come across to know with what all importance does these meta characters have and how can we use it in a better way. Okay, it then passes on the command line to the kernel for execution. Okay, the shell waits for the command to complete and normally can't do any work while the command is running. Okay, till that command is running in a background or else anything, so the shell will be waiting there. Okay, after the command execution is complete, the prompt reappears, that is your dollar reappears there. Okay, and the shell returns to its waiting role to start the next cycle there. Okay, so it is now, like for example, what are these meta characters? Okay, you can just come across here meta characters, you can call them wildcards, you can call them, okay, anything. Okay, now like for example if I have an asterisk, what do you mean by asterisk here? Asterisk stands out for, so you can just come across a meta character. Asterisk is one of the characters of the shell wildcard set. It matches any number of characters including none. Including none is nothing but including nothing, it will be matched out. Okay, now like for example, okay, to match these file names, now I have, so usually you guys will be having an rhythmic way of naming the file there. Okay, you'll be naming it as prog1, prog2, prog3. My prog is remaining common. Now I want to know how many of the files are existing with the first four characters as prog. Okay, how can I get to know it? Okay, so that can be identified by matching up these particular file names there. Okay, now like for an example I have taken here chap01, chap02, chap03, chap04. If these are my file names, then how can I list out only these particular files in my listing? Okay, for listing up of files, which command do we use? We use a command called it as ls. Okay, ls, what are my first four characters here? These are common here, chap. Okay, after this I use an asterisk. Okay, what do you mean by an asterisk? It matches my first four characters. I just say that my first four characters should be chap, and in front of that any number of characters can be there or else even none also. Okay, so what will happen here, my first four characters are chap, so it will list chap any number of characters. Okay, or none I have said. None is even if nothing is there, even if zero nothing is there also is being matched out here, chap. 01 it has been shown, 02, 03, 04. So it ultimately matches out all the string and all the files are being listed here. Okay, keep in mind these files should be existing. Only then you can have a match of these respective file names along with this usage of a meta character. Okay, now in the same way I have one more meta character called out as a question mark. Okay, now what is this question mark? Question mark is used for matching a single character. Okay, so wherein I do not want some listing of the files, okay, and I want now, like for example, assume the same one. Here I have few more files called out as only chap 5, chap 6. Okay, no 0 is been prefixed there. Okay, at that time I can use it as chap. Okay, and then I'll use an question mark there. Okay, but keep in mind your question mark says, okay, compulsory a character should be there. It matches a single character. Okay, your none will not be identified here. Okay, now like for example your chap will not be identified. If I use chap and a question mark, chap file name will not be identified because at least one character should be there after this. Okay, that is how the interpretation happens there. Okay, so now here, now like for example here you can just see that ls chap and then question mark. Okay, if assume I have the file names called as chap x, chap y, chap z, so what it will list me? It will list me all the three files. Okay, sorry, I have made a mistake. I have taken it as capital C. It's not capital C, it's a small c only. Okay, keep in mind it's a small c only. Okay, only that will be replaced. Okay, no capitals, these things will be entertained there. Okay, next one is my first meta character is an asterisk, the second meta character is a question mark, the third meta character is a dot. Okay, whenever I have a dot as a meta character, always keep in mind it is usually used to match the hidden files in your directory. Like if you have any kind of a hidden files, that will be detected using this dot there. Okay, so to list, now like for example my botheration is to list all hidden files in your directory having at least 3 characters after the dot. Okay, now like for example I want to have a listing of all the hidden files there, but provided with that at least 3 characters should be there. At least I said, not at most, at least. Then further whatever are there, even that can be looked across. Okay, because I have used at least 3 characters. Okay, if I use question mark and a question mark, so what do I want to say here? Now like for example ls dot question mark and an asterisk. Okay, what does this dot specify? Dot specifies all, list me all hidden files. Okay, why these 3 question marks here? These 3 question marks because I have said at least 3 characters. Okay, I do not want any file name called out as chba. I don't want them. I want cha as a file name. Got to know my botheration there. At least 3 characters should be there with that particular file. Okay, at least I have used. So that's why, what do you mean by that? Even more than that can also be entertained. So that's why what will I use is question mark and a question mark and a question mark and an asterisk. Okay, so this means that first is a hidden file, next is at least 3 characters with a file name. At least that means it can be more than that also. Okay, now expected, just an example it is, these are all the file names which will be listed under if at all you are using like this. Okay, so this is with matching the dot. Okay, I'll give you at the end of my class, I'll do a thing, I'll give you an solving for you guys so that you can work on it and let me know in my next class what are the answers for that. Okay, next comes is there is one more called out as a square bracket here, and that is called out as character class. Okay, now tell me what is the role of shell here? Every role is played by your shell. Shell is interpreting these things. If your shell does not interpret these meta characters, ultimately you will be not expecting the output what has been shown here. Okay, now this is character class. Whatever is written within this character class is treated as, it is almost like specific characters. Okay, now like for example if I say a pattern called out as ABCD. Okay, if I say take the same example here. CHAP, I use a square bracket, I say ABCD. So what do you mean by that? I'll be telling the shell to look for the file names followed as chap. One each at a time will be replaced. Chap A, chap B, chap C, chap D, file names respectively. Okay, so here you can just see that, for example, if I want to match these file names called as chap 01, chap 02, chap 03, chap 04. So what will I do? What is common here? Chap and a 0 is common everywhere. Okay, I will take it outside. Okay, within character class, what do I use? I use 1, 2, 3, 4. So every time one each will be replaced, and it will be seen whether that file name is existing in the current directory, and then if at all it is existing, then it will list out those file names there. Okay, now here ls chap 0 into bracket 1, 2, 3, 4. It will look out for the first file called as chap 01. It will look out in the current directory. Yes, it is there. It will list out. Chap 02. Okay, it will look out whether it is there. Okay, it will list out. Chap 03. It will look out. Okay, it is there. It will list. So this is a character class. Okay. Similarly, you have one more called as negating the character class. What do you mean by negating? Negating says that apart from that. Okay, whatever is listed here, apart from this, I want the listings. Okay, if I say ls and exclamatory sign 0-9, okay, and then I use an asterisk. So what do you mean by this? I want to match all the file names that does not begin with a digit. No digit should be there, and I want listing of such file names there. Okay, then similarly I have asterisk I use for match any file, extensions, accept, okay, accept that particular thing. Okay, so these are the things. Okay, I'll give you some time for that. Okay, later you can come across. Thank you.